Continuing our discussion of assembly language, we are going to actually step through this program in the debugger in order to see how all of this works. So, again, if we look at our code, sometimes you can get a little lost here. Sometimes it's easiest just to exit your program and rerun Immunity. So, once again, I'm going to pull up my buffer overflow program and it's going to start me kind of near the beginning of this program. There's some preamble code that has to execute. And we said last time, if we scroll down a little bit, this was in fact our function code followed by our main code. So in order to run this program, we want to do a couple of things. The first thing we need to do is we need to go to the debug menu, give this program some arguments, because if we don't, this program is going to crash. It wasn't well written. If you don't give it a command line argument, it will be unhappy. So we're going to give it one that's in range 1, 2, 3, 4, 5, 6, 7, 8, 9. We said that that should be the longest string that I can give it. We'll say, okay, you have changed it. You must restart the debug program. Well, we haven't even started the debug program, so that shouldn't be an issue for us. So now we want to set something called a breakpoint. So if we set a breakpoint, if I click on a certain line, so here, for example, I'm loading the value into main function. If I right click onto this value, you'll notice there are a couple of different options, and one of them is breakpoint. And I can toggle a breakpoint. I can also just press F2. So I'm going to click on toggle, and notice now this line appears differently. It has highlighted that particular line of disassembled code. So if I go up here and I click on the play button to run this program, it will run to that line. So as I look at this program, I'm looking to see what's changing in these registers, but perhaps more importantly, I'm looking at this stack over here. So the stack is a place in memory. It's kind of a temporary place where you push things on it and you pop things off of it. Now, every program that runs has at least one function, and that function gets called. Its local variables get put on the stack. We talked about this a little bit briefly when we talked about different kinds of buffer overflows. Other information is also pushed on the stack every time a function is called. Some of that would include things such as the return address. Let's run through our program here. And if you look up here, you'll notice that there are a couple of options. We have a step into, a step over, trace into, and trace over. So if we go ahead and call step into, you could also press F7. It will call this line, and then it goes to the next. And you will notice I am copying different values into memory locations. So nothing too exciting here. Now, here it says call to this memory address, 401290, which we said previously is the address of function. So I'm going to go ahead and step into this and watch what happens here. Here's my stack. It ends at 22FF50. Now, in Linux systems and many other systems, the stack grows upward. So this value should go down if my stack is going to grow here. So I'm going to go ahead and step, and notice that it did just grow. At the top, it says return to buffer overflow 4012EF from this location. So the very first thing that happened when I called the function is that it pushed the return address onto the stack. So the return address is the memory location that you have to go back to as soon as this function is over. So it will be the memory location just after the call. We can verify that pretty easily if we scroll here down to 412EF. You'll see that in fact, that is this location just after that call. If I step again, I see that more information has been pushed onto the stack. And now we'll step again, and I've subtracted 8 from the stack. In other words, I've said, let's make some room on the stack. What am I going to do with those 8 bytes? Well, look at the next 2 lines. I'm going to move a memory location for my function string and also for my integer. So that is exactly what has just happened. Now I have memory locations on my stack. And if you look here, you'll see that is the location of function. And here is my integer value. The integer value is reversed from what was in our program because it's little ended. Next, I step again, and I've gotten to the move call. So I've moved the value of 1 into EAX. I look over here at EAX, and sure enough, I have the value of 1. Now, if I call leave, leave has a special significance. It will start to unwind the stack. And notice it popped off my 2 values. And now at the top of the stack is this return address. It says return to this from my call. I step again. And now I'm back into my main function. I'm going to move 0 into EAX. I call leave again for my main function. And we'll see some things popped off the stack here. Then I call return. And everything behaves as it should. We're going to take a quick break. When we come back, we're going to make this program misbehave and see what happens.